For our notes for 3.2 part 1, we are going to be learning about what the multiplicative inverse or a reciprocal means. So multiplicative inverse and reciprocal mean the same thing. So we're talking about dividing fractions, but the opposite of divide is to multiply. These are partner operations. You can flip them and do them backwards and they mean the same thing. So a multiplicative inverse is when you have two numbers whose product is 1. So let me show you what we mean here. So two numbers whose product is 1 is our definition. If we have 3/5, if we use the reciprocal, right, flip it upside down of 3/5, it becomes 5/3. And product tells us the answer to a multiplication. So if we multiply, 3 times 5 is 15. 5 times 3 is 15. 15 divided by 15 is 1. So their answer is 1 because we just multiplied by its opposite. So when we're dividing, there are lots of numbers that won't nicely go into each other, right? If I do 7 divided by 3, 3 doesn't go into 7 nicely. But if I flip it and use the opposite, then I can just multiply instead of divide. So you may have heard your teacher call it, right, copy, dot, flop, or KFC, keep, flip, change. What we're talking about is the multiplicative inverse. We are multiplying by the opposite of what it was. So let's take a look at this problem here. So we have 12/18 divided by 3. So the first thing we want to do is write down the problem. So it's been written down for us here. Second, we want to use the multiplicative inverse or copy, dot, flop. So we copy the first one down. We keep the first one the same. We change the divide sign to a dot, right? We're now multiplying. Opposite of divide is multiply. And then we have to flop the second one and use the reciprocal of the second number. Do not flip the first one. The first one stays the same. This is what we have. And now we're multiplying by the opposite of the second number, the divisor. So we use the multiplicative inverse. We want to cross reduce if possible. So it's not always possible, but I always want to crisscross here and see if I can simplify these. So 12 and 3. Can anything go into 12 and 3? Yes, 3 can. 3 divided by 3 is 1. 12 divided by 3 is 4. So now I'm making smaller numbers here. Now I have 4 and 18. Can anything go into 4 and 18? Yes, they're both even. 2 can. So 4 divided by 2 is 2. 18 divided by 2 is 9. So I cross reduce. I have much smaller numbers to multiply. Rather than doing 18 and 3, now I only have to do 9 and 1. So now step 4 is we want to multiply our numerators. So 4 times 2 is 8. And last, we're going to multiply our denominators. And 9 times 1 is 9. And because we already simplified ahead of time, now 8/9 is already as simple as it can be. There's nothing that goes into 8 and 9. We've already reduced that problem. When you do it ahead of time, I don't have to multiply such big numbers. And 2, then my reducing is already done at the end. So to review, we write it down just like it says. Then we use the multiplicative inverse, keep the first one, change it to multiply, flip the second fraction upside down, use the reciprocal, cross reduce if possible, multiply the numerators, multiply the denominators, and reduce if possible if your numerator is larger. If we end up with an improper fraction like 7/3, we would want to say, right, 3, 6, it goes in there 2 times. 6 to 7 is 1 more out of 3. Or I can do 7 divided by 3, right? That goes in there 2 times, which is 6. There's 1 left over, 2 and 1/3. So if you do have an improper fraction, you will need to change that over to a mixed number. But here's your 5 steps, and you should have this example here on your page as well.